Welcome to Engage Math Lesson 28, Problem 3. And this is a light bulb problem. It'll be a little challenging, but I think you can do it. So let's get started. All right, we have a streaming company, and I'm assuming that you read this problem already. I'm going to zoom in so you can see everything really well. So let's get going with the first question, part A, assuming again that you read that. So write an expression for the price of a subscription after X $1 increases. What I'm going to underline in that problem is that they are asking us to let X equal the number of $1 decreases in the subscription price. So the original price was $12 per month. So we're going to say the new price is going to be $12 per month minus the number of $1 increases. And if you want, you could put a 1 there. So if there were X $2 increases, we would say minus 2X. But every time that there's a decrease, we're going to subtract $1 from the price. So our expression is 12 minus X. Now we have to write an expression for the number of subscribers. So you might think, why would any company lower their price? Well, the reason is because of supply and demand. And if you think about it, if the price is lower, the demand, the number of people who will want to sign up will most likely go up. And the research here shows that the 80,000 subscribers that we originally had at a price of $12 is going to go up by 10,000 subscribers every time we lower the price. So a lot of people will sign up just because the price is lower. All right, so that's going to be the number of subscribers we have. So now we're going to say the revenue that we have, the revenue is a function of X, and revenue is always the total amount of money that you take in as a business. And the way we get the total amount of money is we take our price, the 12 minus X, times this part right here is going to give us the total number of subscribers. So we're going to have 80,000, and then we're going to have plus 10,000x. So this expression right here represents our total revenue, the price times the number of subscribers per month. So that's our monthly revenue. So now, when we see the word maximize, you want to think about the fact that we know with quadratic functions, the maximum and minimum point is always going to be, the maximum or minimum point is always going to be at the vertex. So the way we get the x-coordinate of the vertex is by saying the x-coordinate is equal to the opposite of b over 2a. So this is going to help us in real world applications. All right, so we're going to do this. I think you can use a calculator if you would like on this problem, but we're going to try it without a calculator. So let's do it. So we have 12 times 80,000. So the way that I'm going to do that, just to show a little bit of mental math here, is 12 times 8 is going to be 96. And so we have a 96, and then we have 4 zeros. So it's going to be 960,000. And then we're going to have plus 120,000x, because I'm doing double distribution. And then we are going to have minus 80,000x. Okay, I'm still distributing. The 12 went to both terms, and the negative x is going to both terms in the second parentheses. Sometimes this is called FOIL. I'm a big fan of thinking of it as double distribution. All right, and then we are going to multiply the negative x times the 10,000x, giving us a negative 10,000x squared. Okay, we're going to combine our like terms, and I'm going to purposely put this into the order where, I'm going to say revenue of x, I'm going to put it in the order, descending order or standard form. So what I'm going to say right here is that r of x is equal to a negative 10,000x squared. By the way, I knew that the leading coefficient on x squared had to be a negative because this graph has to open downward in order to have a maximum, and we're trying to maximize. So negative 10,000 x squared, that's done. I'm going to combine these two x terms, which is going to give me plus 40,000 x. Okay, that takes care of these two terms, and then plus 960,000. Okay, so we're going to now use the fact that we know the x-coordinate of the vertex, which is going to be our price, or sorry, not our price, but the number of decreases in our price. So X is going to be equal to negative 40,000, because negative B over twice A. So it's going to be over 2 times negative 10,000. Okay, when we simplify that, we're going to get a positive 2. So we know that we should have, just to remind you, I'm going to go back to one thing here. The 2 in this case is equal to the number of price decreases. The original price was 12, so we can just put 2 into this expression, and our price that will optimize our revenue is $10 per month. So then the way that we get our maximum revenue, when you think about it, we could either use this revenue form right here, or we could think, okay, our number of subscribers went up by 20,000, because every time we lowered our price by $1, the number of subscribers went up by 10,000. So the maximum revenue would be 10 times 100,000, which is going to be $1 million. That's the maximum revenue we can achieve in this problem. Okay, great job. See you next time at Engage Math.